Hey, welcome. Have you ever looked at, a slice of pizza or maybe a spinning fan and wondered about the geometry that's just hiding in plain sight? Well, today we're going to dig into the simple, elegant math behind all these familiar shapes. Let's dive in. The thing is, we are surrounded by these pieces of circles all the time, but we hardly ever stop and think about how you'd actually measure them. I mean, they look like these weird curved shapes that would need some crazy complicated formula, right? But you're about to see just how surprisingly simple it all is. So let's kick things off with a little puzzle. Picture this. You've got a horse, and it's tied to a post right in the corner of a big square field. The rope is a certain length. So the question is, what's the exact area of grass that this horse can graze on? It's not a full circle, obviously, so how would you even start to figure that out?
And it's really the exact same kind of problem when you look at an umbrella. It's made up of all these identical panels, right? And each one of those is just a slice of a much bigger circle. So how could you find the area of just one of those panels?
Okay, and one more for good measure, a car's windshield wiper. As it pivots back and forth, it clears this very specific curved shape on the glass. And yep, it's yet another piece of a circle. All these problems might seem totally different, but they all share the same geometric secret. So this brings us to the big question, doesn't it? How can we find a simple, reliable way to measure these super common but kind of weirdly shaped pieces of a circle? Well, the solution starts with just giving them the right names. See, to solve our puzzle, we've got to have the right vocabulary first. As soon as we can name these shapes, we can measure them. And it turns out there are really just two key terms we absolutely need to get down. So first up is the sector. A sector is simply the area of a circle that's trapped between two radii, that's two straight lines from the center to the edge, and the curved arc that connects them. Honestly, the easiest way to remember this, it is a perfect slice of pizza. That's it. Now, our second shape is the segment. A segment is the area that's bordered by a chord, which is just a straight line connecting any 2 points on the circle's edge, and the arc between those 2 points. So if the sector was the whole pizza slice, the segment is really just the crust. All right, so let's put it side by side, because this is the key difference. A sector is pie-shaped, and it always includes the center point of the circle. A segment, on the other hand, is sliced off by a straight line, that chord, and it never includes the center. Nailing this distinction is absolutely crucial. Okay, so we've got the names down. Sector, segment. Got it. Now we need the tools to actually do something with them. And in geometry, our tools are formulas. We need to find the one that lets us calculate the area of a sector because that is the key to solving all our puzzles. We've got a good place to start. I think most of us remember from school that the area of a whole 360-degree circle is pi times the radius squared. So it just makes sense that the area of a part of that circle has to be a fraction of the total area, doesn't it? The logic here is actually beautiful. It's so simple. If the entire 360 degrees has an area of pi r squared, then a teeny tiny 1-degree slice must have an area of pi r squared just divided by 360. And from there, it's a super easy step. To find the area of a sector with any angle, we'll call it theta, we just multiply that little 1-degree area by our angle. And boom, there it is, the master tool for our toolkit. The area of any sector is just the fraction of the circle it takes up. That's its angle, theta, over 360 times the area of the whole circle. It's so elegant, so simple, and incredibly powerful. And now for the best part. We've got the words, we've got the formula. It's time to circle back to our first puzzle and really put this tool to the test. Let's find out exactly how much grass that horse can eat. So, here we are again. The horse, the rope, the square field. What looked like a tricky word problem before, now we can see it for what it really is. A pretty straightforward geometry question. Let's just break it down. Okay, the horse is tied in the corner of a square field. So the angle it can graze inside the field is a perfect 90 degrees. That's our theta. The rope is 5 meters long, so that's our radius. And the shape of that grazing area? Well, now we know it's a sector, a quarter circle, to be exact. So now we just plug our numbers right into that formula we found. The area is 90 over 360, which is just a quarter, right? Times pi, which we'll call 3.14, times our radius of 5 meters squared. And the answer is 19.625 square meters. That's it. That is the exact grazing area. No more guesswork, just a clean, precise answer. And it's all thanks to our formula.
Puzzle solved.
But, this was never really just about a horse. It was about learning to see the geometry that's all around us and realizing that we actually have the tools to understand it and measure it. I mean, really think about it. The exact same formula we used for that horse can tell us the area of an umbrella panel or the space cleared by a windshield wiper. This stuff is fundamental for engineers designing sprinkler systems, for architects planning curved windows, even for animators creating a radar sweep on a screen. The context is always different, but the geometry and that simple formula stays the same. It's like a universal key.
So, I'll just leave you with this thought. Now that you can spot a sector and you know exactly how to measure it, what other slices of your world can you find? What's the area of that slice of cake on your plate? The geometry's everywhere, just waiting for you to measure it. Thanks so much for tuning in.